the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New and Geocentric Consultants Hugo New Corporation Sustainability Seminar Series, co-sponsored by Brown & Caldwell, H2M Architect and Engineers, BEM Systems, Catalyst Group, and WSP.
Okay, thank you, Dibs, for that introduction. And I noticed, I'm going to talk a lot about residential recycling, but I noticed that our sponsor for the Sustainability Seminar Series was a well-known metal recycler for many decades in the business, and certainly we know them. So appreciate the opportunity, and thanks to the sponsors for the series. So I titled my presentation North America Recycling Megatrends. And like many things, we all recycle. Most Americans do, certainly people in the eastern US and New Jersey, we all recycle, but it's kind of like the back of the yard that you don't see. You put your recyclables at the curb and they disappear. And I'm going to go into kind of how we got to where we are right now in recycling and what's behind the recycling industry in North America. So there's my Stevens title slide, which if you go online to do a presentation for Stevens, they give you a title slide. So Dibs mentioned I'm a chemical engineer and by education from Stevens, but I became an environmental engineer self-taught in the 70s before that degree existed. So I've really been an environmental business professional for long before it was fashionable. I've worked in air, water, hazardous waste, Superfund, groundwater, was a certified hazardous materials manager. And then I worked my way into the recycling business in the middle 1980s. And at first I specialized in plastics recycling, and it's been some time now that I'm specializing in paper recycling. So Dibs also mentioned Moore & Associates. Here's just a little slide. We're essentially commodity experts in a sense. We're not so much technical folks, but it's a long way from chemical engineering, but like many Stevens grads, it gives you the basis to do lots of things. And behind the scenes, it's a big business. The global trade in recovered paper is 250 million tons, not an insignificant amount. And when you think of it, it's kind of amazing. We make all these corrugated boxes and we distribute them in commerce all around the world to individuals, businesses, households, and we bring 80% of them back to make new boxes out of it. It's an amazing feat of logistics, the recycling business. So I'm happy to send you electronic Acrobat file of the presentation. If you send me an email, you can either go through our company website or email me directly and I'll send you a copy of the presentation. So let's start with some history. Why is history important? And actually the first dot here, I learned at Stevens in humanities, studying the Greeks, that there's no way to judge the future but by the past. And not knowing history deems us to repeat failures. And it sets the starting point for the future. But it is very important to be able to project forward and especially be able to predict the inflection points. And yes, history is important, but the future is what it's all about. And Dibs and I were just chatting that the future is good for folks in the engineering and science side of the sustainability business. So let's look at municipal solid waste, or whom we call MSW. And MSW is everything that's non-hazardous, non-industrial. So that's residential waste, commercial waste from stores, shops, etc. And if you look at this this graph, this covers the recycling rate, and you can see if you go all the way back into the 60s, we were about 6.5%. You know, recycling has always taken place. I mean, the Romans and the Greeks and Egyptians recycled metals all the time. But we started the business mostly in the metals and a little bit in paper fibers in the 60s. But then look at the fast growth rate from the 70s through 2010. We went from nominally 6.5% up to 34%. But you can also note that we've kind of flattened out in the last 10 years and actually retreated a little bit. And we'll go into that a little bit more as the presentation progresses. So disposal costs are really a big driver of recycling. We like to say that there's three pieces to recycling. One is the markets, the end markets for the material, when avoiding disposal cost, and disposal cost tends to be linked to legislative and regulatory. And if you look at this chart, you can see, except for in the early 2000s, US average MSW gate rates, that's what we use a term called disposal, has steadily moved from in the low 20s in the early 90s up to where we are now, about the mid 50s. And that's a fairly significant move. Actually, what really happened in this time frame was this is when recycling really took off in the US and North America, and it cut the amount of disposables and took disposal costs back down. So 1970 was a really big year. It was the first Earth Day. Most people know about Earth Day coming up in April. But the first Earth Day was in 1970, and it led to the passage of the National Environmental Policy Act, NEPA, which was the first broad US national legislation and policy promoting enhancement for the environment. And the EPA was formed as part of NEPA. And NEPA led to the Resource Conservation and Recovery Act, which regulates solid and hazardous waste. But NEPA also led to all the other Clean Air Act, Clean Water Act, and Safe Drinking Water Acts. And while RCRA applies to solid waste, the early years were mostly focused on hazardous waste. And while not a solid waste issue, a name out of history now, Love Canal, which was a hazardous waste-induced groundwater contamination site in western New York in the mid-70s, really added fuel to the groundwater hazardous waste issues. And that led to the passage of what we call CERCLA, or commonly known as Superfund, the Comprehensive Environmental Response Compensation and Liability Act, which is for cleaning up old hazardous waste sites in the US. So solid waste is regulated under the Resource Conservation and Recovery Act, but there was not a lot of direct attention to recycling in it. It did address the recycling commodities market and required the federal government to purchase some recycled content products such as paper and motor oil. And this approach to end market stimulus has become a model in many states, and even the private sector has followed that with giving preferences for recycled content. But the most important effect of the RCRA Act on recycling was it set the environmental standards for disposal of municipal solid waste. It's called Subtitle D of the Act. And it forced the closing of substandard landfills. In the 50s and 60s, we called them dumps. They were unlined, they contaminated groundwater, and RCRA really set the standards for modern lined landfill. And it caused disposal costs to steadily rise. If you looked at disposal costs in the 50s and 60s, fairly flat. It was mostly the cost to transport the waste to the disposal site. And again, the cost of disposal is a major driver for recycling. So modern recycling collection sort of started in the 70s in the US, and up to the 1980s, it primarily took place at scrapyards focused on metals, people like Hugo being a big player, and what we call paper stock, which were paper recycling plants. They weren't residentially oriented. They were buybacks where you took your cans or metals and iron and aluminum and copper in and you got paid for it. Then there were some newspaper drives. The Scouts and other civic groups ran drives to collect newspapers. Some of you might remember what a newspaper is. There aren't many of them out there anymore. And commercial industrial recycling has always happened on an economics and market supply demand basis. One thing I learned was to be a person who understood supply and demand, because that's what drives commodity markets. And there were a few old newspaper, ONP, as we call it, household collections in the early mid 70s, and even some activity in the 60s as the first recycled fiber newsprint mill emerged in North Jersey in Elmwood Park and in Chicago. But the first real multi-material residential recycling programs, which is what we call our curbside programs now, that when you put your materials out in a bin or a cart, started in Massachusetts in the middle 70s. And recycling, curbside recycling really came to age in the middle 90s. Almost at the same time, there were 3 different residential curbside collection programs emerged with different approaches. There was the Northeast, New England, New Jersey, where there was what we call dual stream programs. The household had 1 bin, maybe with 2 compartments on the truck, and the truck drivers sorted the material at the side of the truck, usually one for old newspapers and the other for containers, steel, aluminum cans, and glass. And materials were sorted at the first generation of what we call MRFs. And I've defined it in a couple bullets down, but they're material recovery facilities. And after the trucks bring the recyclables in, that's where things are sorted, processed, and packaged for shipment. The other area that started in the 80s was in Ontario, Canada. It's called the Blue Bin system there, and it featured collection vehicles with 3 or 4 bins on the truck. And materials were all sorted by the truck drivers, very expensive. And then in Northern California, actually in Sonoma County, they pioneered what was called the 3-bin system, which had 3 bins for the household, stackable, and the truck. And one was usually for old newspapers, one was for metal containers, and one was for glass containers. And it was processed at simple material recovery facilities. And New Jersey actually has always been on the cutting edge of recycling for many decades. So the space in the state where Stevens is, and a lot of you come from in and around, is known for its recycling attitude. So this was what the early bins looked like. They were small, they were 12 gallons, and this was the Blue Bin box from Kitchener, Ontario, started in '81. So then curbside recycling hit a real turning point during the middle 80s. San Jose decided to hire Waste Management to implement a citywide residential program after piloting in a small area. And they used pilot programs early on because they wondered whether people would participate and whether they would work. And San Jose, after running their pilot, and San Jose at that time had a population of about 750,000, implemented a full large curbside program. And at the time, the 3-bin program was popular in California, modeled after the Santa Rosa program, and that's what San Jose put in place. And then in Canada, the second largest one in '86 was Mississauga, which is a suburb right next to Toronto. And they had that was a fairly sizable program for its time. Now we think of curbside recycling as the norm. If you go somewhere and you move and they don't have curbside recycling, you say, what's going on here? So the multi-material processing facilities, or MRFs, in the early years, the paper stock plants and scrapyards were the earliest processing facilities. But some of these emerged as the first true multi-material material recovery facilities. Peter Carter, I call him the godfather of the modern MRF. He came out of Connecticut, and the first real MRF I ever saw was in Camden, New Jersey, and it was a scrapyard in the late 80s. And he also had a number of operations in Connecticut. So there are 3 types of MRFs and 3 types of collection programs out there. And you can see this bar chart, which goes back to 1980. And the green bar is what we called highly source separated. And you can see that that was where people were sorting 3 and 4 and 5 bins at the side of the truck. And you can see by the early 2000s, it just about disappeared. And what emerged was 2-stream, which actually there are more 2-stream programs in New Jersey than almost anywhere else. And you can see they emerged in the 80s and they became pretty popular, but then they started to decline a little bit. And the single stream program here in gray, which is where the recyclables are all put in the same bin on the truck and then sorted at the MRF. And you can see probably 75% of the US curbside business is single stream. So things really accelerated in the late 1980s. There was a barge called Mobro, which took solid waste from Long Island because there were no more disposal facilities in Long Island. And we called it the Flying Dutchman in the solid waste business because it wandered around the Atlantic Ocean looking for a home for like 6 months, going as far as Belize, and nobody would take it. They would say, hey, we don't want New York City garbage. Why? Go back to where you found. And they went to North Carolina, they went to Virginia, they went to Florida, and ultimately it wound up going back to New York, to Long Island after 6 months where it was incinerated. But you can imagine having this happen. It was in the news, it was on national TV, and it really pushed the modern solid waste business and recycling business ahead. And also at the same time, a number of these old dumps were closed because of the implementation of Subtitle D of RCRA. And there was a perceived shortage of disposal capacity in the US. Landfill costs skyrocketed, and a number of very costly and expensive waste to energy plants were built. New Jersey has a lot of waste to energy capacity, what we call mass burn. New England, New Jersey, and Florida probably have the most. And at the same time, this perceived shortage and the higher disposal costs spurred on a number of states to enact recycling legislation. And as we went into the 1990s, residential recycling really grew from the early start to almost implemented in 70% of the US. And I mentioned the 3 types of earlier types of collection, but new materials started getting added. The first time we saw plastics being included in residential materials, and but usually only the 2 materials: PET, polyethylene terephthalate, think soda bottles, HDPE, high density polyethylene, think milk jugs, clear milk jugs, or detergent colored things. They went in at first. And after starting out on with newspapers only, additional paper grades were added, what we call old corrugated containers, brown corrugated boxes, and then all papers, mail, any office papers were included. And the single stream programs started to emerge in the 90s, pioneered by Waste Management. And towards the middle to later 1990s, that truck side soared and 3-bin trucks started to disappear because the collection costs were just too high. Having that guy go out or person go out and sort it at the truck led to some very costly collection. And by the end of the 1990s, the dual stream collection was still leading, but single stream was gaining. And then when we got to the 2000s, single stream continued to gain market share. And we started to see some mixed waste processing where you take the entire municipal solid waste stream and you try and sort it out. They have not been very successful in running programs like that. We started to see organic recycling at the curb. Yard waste is a pretty common recyclable, and it's handled for composting. And that was the first large organic, and it's a large part of the municipal solid waste stream. And then other new materials were added: poly-coated packaging, what we call aseptic packaging. If you think of juice boxes and little milk cartons that don't need refrigeration, those are called aseptic packages, and they were included, plus other poly-coated things like poly-coated milk cartons. On the commercial, institutional, and industrial side, that business has remained fairly similar over the last 30 years, but with efficiency improvements. And there is also some single stream commercial and institutional industrial recycling. And what happened in the 2000s that was really negative for recycling was the commodity qualities started to deteriorate as the collection system grew and recovery rates went higher. And people were putting anything in their bins just because it might be recyclable. And we'll go into that in some detail because that's still a serious problem for the recycling system here in the US. So here's a number of operating MRFs in the US, and not unlike some other charts that we've had, you can see there was big growth from the early 90s to the about the 2010 time frame, and we really kind of leveled out. So we're kind of at a plateau. And that has some issues with it because we're still only at the roughly 35% recycling rate. And actually, most states want to go much higher than that. And they're somewhat stalled. California and some of the West Coast states are probably up around 50% recycling right now, but there's a lot of states that are less than 25. And here's that growth in single stream MRFs again. You can count them on one hand in the mid 90s. And by the 2000 teens, we had almost 300. So in the 2000s, the greening and sustainability movement took hold in both the general public and business and government to follow suit, and it spurred recycling even further. And one of my takeaways, since I've been in the green, environmental, and sustainability business for a long, long time, in the first 30 years, every time we had a downturn in the economy or downturn in business, people who were working in that area in the government and in the business kind of got furloughed. It was always the first thing to go. What I've noticed in the last 10 years is it's now a mainstay part of life, and both at the government side and the business side is it's so important that those people are now retained and are sought after to make decisions about sustainability. It really caused a change in attitude of the generators of municipal solid waste. Packaging designers now want to consider recycling all around. And we've had an emergence of what we call extended producer responsibility. And you'll probably hear more about that. Several states passed last year. I suspect New Jersey will be in the next batch, so Pennsylvania and New York. And that's where the retailers and the packaging producers are becoming responsible to produce packages that are more easily recyclable or pay a higher price to use those packaging. And partly because of the recycling, the amount of municipal solid waste disposed of begins to decline in the 2000s. I pointed that out, that disposal costs actually went down and disposal capacity was not an issue. And recycling really became not mainstream. And sometime in the early 2010s, the quality of recyclables kind of bottoms out. And there was increased interest in mixed waste processing. Again, no one's been very successful in that. And as we get closer to 2010, the anti-plastic movement, which you just hear everywhere, starts to accelerate. The pushback against plastic packaging, single-use packaging, plastics in the ocean. It's a juggernaut on the plastics recycling side of the business and plastic packaging. And we got complacent in the US. China became the manufacturer to the world in the 2000s and really took a lot of manufacturing capacity from the US. And a lot of that capacity was based on importing recyclables. China ramped up and was importing large amounts of recovered paper, plastic, and metals, raw materials for the industries. And imports came from everywhere in the world. We used to say back in the day when we still had newspapers, you could read your newspaper in New York City, put it in your recycling bin, and 6 weeks later, a person in Shanghai reads their newspaper on the same fiber that you read in New York. They were importing from the Middle East, from Africa, from the Caribbean, all over. But because China has some real environmental issues, especially air, it's just across the board, it's air, solid waste, groundwater. And one of the solutions was to say, hey, let's stop bringing this garbage from around the world, beginning in 2016 with Operation Green Fence and then National Sword and Blue Sky, which ratcheted down on import recyclable commodities, commodity quality. And but the manufacturers in China certainly didn't view this as garbage. They viewed it as raw materials. And as China started to do this, the recyclable market prices started to tumble. And China imported a full ban of paper and plastic and a number of metals, recyclables, beginning in 2021, just last year. And from 2020 onward, the market for recyclables repositioned around the world to other South Asian countries. Vietnam, Thailand, Indonesia, and India have all ramped up their imports of recycled fiber because they don't have the tree assets that we have in North America, and also they don't have the petroleum assets. So a lot of the plastics were being used. But also, we've seen real expansions in the US to use recyclable feedstock as raw material, both on the paper fiber side and on the plastic side. You know, the aluminum, scrap steel business has always had a lot of recyclables, and most of the new steel mills built in the United States in the last 20 years, which haven't been a whole lot of them, have been based fully on scrap. The blast furnace iron ore industry kind of topped out quite some time ago in the US. So here's a chart showing recovered paper exports to China from the US, and going back to 2015, which was the last year they purchased a lot from us. It was almost 16 million tons, and last year it was zero. And that's quite a decline. To find a home for 16 million tons of recovered paper that was going to one country was a real challenge. So this chart starts to drill down a little bit into recovered paper globally. And I'll spend a little bit of time on this because there's some acronyms here. So these are the four major grades of paper that are traded around the world. I mentioned OCC, which is really corrugated boxes, and you can see that by far it's the largest recyclable, and it's really been growing. And it's gone from just over 70 million tons in 2000 to 175 million tons in this past year. Mixed paper is really a mix of everything you can think of. It's got some packaging in it. It's got mixed mail. It has a lot of other materials, and it's recovered at a much lower level, but it's starting to turn up. If I did this graph without OCC on it, you would see that the orange bar mixed paper is turning up. I mentioned ONP a few times, old newspapers, and OMGs, old magazines. It's really been declining. You can see the green line going down. The peak of newsprint use in North America was 1998, and there were 30 recycled newsprint mills in the United States. There's one left, and the use of newsprint in North America has declined by 85%. The high grades, you think of office papers and other high bright white packages, pharmaceutical packaging. It's also starting to turn down too, because we have much less office papers that we're using as we progress to the digital world. So the US is ramping up a lot of new manufacturing capacity to use our country's recyclable, which is a really exciting time. We've been exporting these things for so long, and starting in about 2018 when China backed out of the market, and continuing, and for the next 3 years to come, significant new domestic capacity is coming online to process all these recyclables, paper and plastics being the key areas. And the reasons are different for the two materials. The main reason that paper recycling has been booming and the production capacity to produce recycled fiber paper is corrugated boxes for e-commerce delivery. That's been the savior of recycling, all those packages we get at our doorstep. And, I told you the story about newsprint. The story about corrugated boxes, if you put your corrugated box at the curb in your recycling cart that Amazon's delivered to your doorstep, 6 weeks later in Thailand, the same fiber that made that box is in a new box that Amazon delivers to somebody in Thailand. So it's just amazing that it goes around and it's global. Although I emphasize the global a lot, but 80%, 75% of recyclables collected in the US now stay home. The plastic reclamation facilities that have been built it's a slightly different driver. The corrugated box business is pure economics. The lowest cost way to make a corrugated box is from recycled fiber. Plastics have been a different story. They're much more difficult. The fabulous thing about plastics is the polymers that have been developed, package materials, are unique. They're great packaging, but it also makes them difficult to recycle. You have a lot of multi-layer materials, And most of what's being built right now in reclamation facilities in the US are to satisfy recycled content requirements by government and product sellers to counter the anti-plastic movement. I mentioned how important that is. You can't go a day without reading about some plastic pollution issues around the globe. So I mentioned extended producer responsibility. It's a happening thing right now. It's aimed at taxing packaging, especially with regard to the difficulty of recycling it. And 2 states, Oregon and Maine, passed comprehensive laws in 2020. Before this, EPR type things were aimed at special recyclables, car tires, electronics, batteries, things that didn't find their way through the recycling system easily, had separate collection. But now EPR is being aimed at consumer packaging, and many people believe it's the future of recycling. And actually, the retailers and consumers are strong supporters of EPR as the magic bullet to solve the packaging recycling problems. The first global traction for EPR was in Europe. Germany had a program called Green Dot, and Canada has 4 or 5 or 6 provinces that have EPR. And one of the most important things is that it probably provides good state and local funding for recycling program. People always say, well, why do I have to pay for recycling? It's actually a fairly expensive process to do. And if you're in a state with low disposal costs, recycling is probably costing more than disposal. If you come into the Northeast and New England and Florida and the West Coast, a lot of the recycling is purely economic. It's lower cost than disposal. So organics recycling, I touched on that earlier. It's actually a large part of the waste stream, and yard waste came on quickly in the 80s, and it's kind of the norm now. But the new frontier is food waste and anaerobic digestion. Digesting with anaerobic bacteria to produce gas is an old idea. It's always been around in the biosolids world for wastewater treatment, but it's actually gaining traction in food waste. And you do see a lot of commercial anaerobic digestion. What was once put into landfills and disposed of from the food packaging plants and even spoiled vegetables from supermarkets and all are now being anaerobically digested to produce methane and energy. So food scrap recovery is poised for growth, but it has some real challenges, as you can imagine. Food scrap, we think it's the next frontier for high diversion goals, and there are mandates and disposal bans coming up in some states on food scrap, and not quite up to speed so much on the Northeast in it, but the collection and processing infrastructure are really immature and not well integrated. It's just getting started. And the organic recycling facility capacity is probably insufficient to meet the real demand. And the regulations are inconsistent and not standardized. It's not nearly as coordinated as what we call the hard material recyclables like paper and plastics, glass, and metals. So I mentioned anaerobic digestion a couple of slides ago. It's really renewable energy from organics, and we're getting fairly standardized in designs, and there's a lot of vendors for high solids digesters. And the business models include diverse product streams, digestate, biogas, electricity and heat, and energy recovery is essential to financial viability. Almost all the major landfills in the US, of course, also collect methane gas. You can think of a landfill as kind of a natural anaerobic digester, and it produces methane, which was at one time just left to go out in the atmosphere, and then it was flared. But most landfills recover the methane from the digestion process and produce electricity. Manure digesters on farm economies and nutrient management are very common. What was once disposed of is now being digested to capture the gas and energy. So other recyclables, I haven't talked much about glass, but it's certainly part of the recycling business, but it has a number of issues. Glass value is very low. And why is glass value low? Well, the virgin raw materials to make glass, the largest one is silicone, and the Earth's got a lot of silicone. And the second most important raw material is soda ash, and there's major deposits of soda ash in a number of locations around the world. So the competition for the raw material isn't very much. But recycling glass does save energy, and that's kind of what's driving it, as well as the desire for the glass manufacturers to have a recyclable product. But one of the big problems is broken glass, which in the collection process and the handling process for glass containers and bottles, the broken glass is very abrasive at the MRF and causes significant equipment wear, and glass has been taken out of some programs just because of that. Metals in residential recycling, mainly aluminum and tin. What we call a tin can is really a steel can with a small tin plating, are the primary ones in residential recycling. They've always been good recyclables and have been included from day one. So here's a little bit of a complicated bar chart with some numbers on it. I'll go through some of the highlights. So this is the fiber use in US paper and paperboard production. And paper, when you think of papers, you can think of office paper, but also tissue and towel products and napkins are considered paper. Paperboard is the material that goes into corrugated boxes and gray boxes. Think cereal boxes, other food boxes. So the green bar is the total production of paper and board in the US. And we peaked out in 2010. And you can see we've been on a steady decline, and we've lost 10 million tons of production capacity in the last 10 years. And that's mostly been a decrease in newspapers and what we call printing and writing papers. Corrugated boxes have been increasing greatly because of e-commerce. And the other paperboard boxes, the gray boxes, have been kind of static. But even in the face of 10 million tons of lost use of paper and board, if you go down to the blue bars, that's recycled fiber content used by all these mills. And we've added 5 million tons of recycling capacity. So you can see the recycled fiber share of total production back in 2009 was 33%. It's grown 10 points in the last 10 years amidst of less paper to recycle. So it's a pretty interesting story. And again, that's because the economics of using recycled fiber is clearly there. So I talked about commodity things, and this is old corrugated containers. Number 11 is industry jargon. This is standard corrugated boxes. And you can look at these are annual values. They're all over the map. If you go back to the early 90s, that's when recycling was really ramped up and we oversupplied the markets. And you can see the values are quite low. And if you look at the other bottoms, this was a recession year. There's $55 in 2001. And this was the Great Recession of 08, 09, where there was a bottom. And this one, however, this bottom is prices really plummeted when the economy was good. And this was when China stopped buying. And a lot of this is China driven. This peak here is China. This is when China started to ramp up. This peak was when China was buying heavily. And this was the last time China bought heavily, and the market really tanked. And 2019 was a very difficult year in the recycling business. But then this is where the US manufacturing capacity started to ramp up and to use the new materials, and prices really came back quite strongly. Very volatile commodities. Deutsche Bank, the German international banking company, did a study of commodities like sugar and grain and lumber, and recyclable steel and paper were the most volatile of all the commodities in the world. So plastics is an important issue. I've talked about it a couple of times in this presentation, not only packaging, but there's global pressure to reduce plastic packaging, and it's a tidal wave that the industry is trying to manage. And it's a real steamroller. It's like managing a real problem that's difficult to solve. And in addition to the number of initiatives on many fronts, the inclusion of recycled content plastic is one part of the solution. If we drive the market by the end use, we'll drive collection and processing. And actually, paper products are benefiting from the anti-plastic movement. But there's a lot of issues, a lot of greenwashing, what we call greenwashing issues out there. And there's a lot of folklore in the environmental business that's just not correct. And I might be a paper person, but I happen to think plastics packaging is a pretty good thing. So the demand for recycled plastic resin is currently very strong. And actually the recent run up in oil prices, when oil prices go up, the price to produce virgin plastic resin go up, and that helps the recycling. But there's also a lack of supply of recycled plastics because they're not in every program and they're not highly recovered. And recycled resin prices up until very recently were higher than virgin. We built a lot of virgin plastic capacity to produce monomers and polymers in the 2010s because natural gas from fracking came on and there was lots of feedstock. But recently, a large number of plastic reprocessing facilities are built to use a range of technologies. And some people think what we call chemical recycling plastic is the magic bullet. You know, if we take these mixed polymers and crack them back to the monomers or to fuel, that may look like an easy way to solve it. But you know, you take highly sophisticated polymers and you crack them back to the monomers, where you spend a lot of cost and time and energy building them up into what fantastic resins they are, and then you crack them back to fuel when you could just be using crude oil or diesel. So that's a tough issue. It simplifies it because you can put all the resins in there, but you know, what are the economics? So I touched on recyclable qualities a few times very early on in the presentation, and by 2010. The quality of what we were producing in the US hit the lowest level because, and it's an inevitable outcome of higher recovery rates. Each new ton of recycling material you recover is probably going to be of a lower quality. But we also stopped educating the public on recycling. When recycling was first introduced in the late 80s and early 90s, there was always an education program that went along with it. But those went out the door in the 2010s. And then we had this problem called wish recycling, where people wish everything was recyclable. One of the latest big issues is in the recycling business is we get a lot of masks, COVID masks, and they're not recyclable. And people wish they were, so they put them in the bins. And that just creates a problem. It's a biohazard. And people put all sorts of things in. We have what we call tanglers, you know, put garden hoses in and carpets, and it was a really serious problem. And for every wrong recyclable you put in your recycling, it carries a good recyclable along with it. An interesting one is pharmaceutical pill bottles. Anything smaller than 3 inches that you put in your recycling bin is going to wind up as residue in the system because of the screening processes. And the domestic manufacturers for paper and plastic had trouble using this low quality material because China built their capacity to process this. And then when the China green fence set the new bottom, the largest impact was on mixed plastic and mixed paper. And there's a number of quality initiatives going on now in the industry and company to help do consumer education. And you'll probably see that coming to your hometown to what we call recycle right and get the right materials in the bin. The average non-recyclables commodities coming into the MRFs averages over 20%. And there are a lot of communities that are higher than 30%. 1/3 of what's going in to be processed can't be recovered and it winds up being disposed of. So you go into all that problem to collect it, and then you've got to dispose of it, and it carries good recyclables along with it. So it's really a serious problem. The best MRFs in the world have 10% residue. The worst are running 30 to 33%. So since we're people in science and engineering, and I thought I would spend some time on research needs in recycling going forward, because I think there are some. And actually, you don't see a lot of basic research happen in the recycling movement. Most of the gains have been, I'll call incremental, and are happening at the commercial scale. You don't see many universities saying we're doing recycling research. But the MRF process, The MRF process in the early years was viewed as a transfer station or a solid waste source, but it's really a manufacturing operation, and it needs optimization, and it's very much a mechanical engineering task. It's sorting, but it's actually similar to food processing plants in many ways, and borrows the technology from that sector. A good example is optical sorting. If you don't know what optical sorter is, when they process corn, for example, lots of corn stalks have black kernels on them in places, and they use optical recognition to pick out the off-colored kernels, and they shoot them out by air jets, so that when you buy your corn in the can or in a frozen, you have nice yellow kernels. Well, that technology is adopted in recycling to kick out different plastic resins. And for example, you can pick up for PVC, you can pick up the chlorine atom and kick that to a chlorinated plastic sector. The second one I point out is how to push recycling and recovery rates higher. You saw that we've really plateaued after several decades of good recycling. How do we get to higher levels without having terrible contaminants? And then I focused a little on plastics recycling, but what's the best option for plastic recycling? And chemical engineering folks and polymer scientists, that's a fertile field, and whether you do it mechanically or chemically, what's the right way? I showed some of those recycling commodity prices, and price stabilization mechanisms are an area that's receiving attention. And actually, New Jersey gave a grant to Rutgers to do an analysis of stabilization mechanisms. Then the next dot I have there is, and New Jersey has the next dot I have is how can we decrease contamination of residential recyclables coming into the MRF? In my day, we used to call it human factors engineering, things like how to design airplane cockpits so that pilots could focus on the right thing, and where to put different dials and gauges in car dashboards. And there's some of that in the recycling business. How do you design a program to get the right materials? In simplest form, if you go to a stadium venue, you'll see the recycling bins have a round hole in, so you can put your aluminum cans and bottles in there, but not fit anything else. So we need more of that, because you can educate the people to a degree, but if you kind of force the behavior by considering how humans react, that's an important thing. A big area of loss for recyclables is multifamily housing. Recovery in multifamily housing is terrible, and it's difficult to work on because people move more. They don't have their own recycling bins. They have to go to big boxes. And we're in the single family residential sector where we recover almost 60%. In multifamily, it's like 20%. And then, packaging design. That's a new frontier, is how to design packaging for recyclability. And as I mentioned with the Rutgers grant, New Jersey being one of the leading states in recycling, in their last piece of recycling legislation, they have a recycling research funding grant available, and they're going to push out several projects. I think this one on price stabilization mechanism was one of the first. So that's